mathematics, it contains the numbers which are all positive or all negative. So when a number we write, say 835, place value wise, unit place, tens place, hundreds place, all these digits they have positive value. So as far as hundreds place is concerned, its value is 800 plus 30 plus 5. So all the digits are positive. When we want to subtract some number, so here the value of 2 at hundreds place is 200 but with negative sign. So it is minus 200, minus 10 and minus 4. So all these numbers are either positive or all are either negative. But the Vedic mathematics, it provides a number which contains both positive and negative digits. So such numbers which contain both positive and negative digits, they are known as Vinculum number. So Vinculum number, it has appeared from the Sanskrit word Vinakulam, of which the part Nakulam means having same characteristics, whereas when we consider Vinakulam, which is the form Vinculum, it is having different characteristics. So the same characteristics means either all positive digits or all negative digits, whereas different characteristics means one digit may be positive, another may be negative, and place value wise we will have to normalize it because we will be expressing the normal number in the normal form. So this is at unit place, and when a bar is given on top of the digit, its value is negative. This is at tens place. So value of 2 at tens place is 20, and the value of 1 at unit place, because of bar, it is minus 1. So 2 bar 1 is nothing but 20 minus 1, 19. So 19 can be written, so this is a normal form where both the digits are positive, and this is Vinculum form. To get the idea how the value changes, let us take one example. So the extended form of 2134 is, which is same as 2134. Suppose the same digits we take, giving a bar on unit place, its value is, the unit place is minus, so its value is minus 4. So 30 minus 4 is 26. Instead of unit, if we give like this, it is 2000 plus 100 minus 30 plus 4. So 2100 minus 30 is 2070 plus 4. If it is, we give bar to any number of digits, accordingly this value is thousands place, minus 100, minus 30, minus 4. So actual value is that. So depending on at what place value the Vinculum number is, accordingly it will be changed. And now we will take another set of examples. So the value here is 1000 plus 700 plus 80 plus 9. So 1789. Just I will write the another form of this number. 179 bar 1. So when a particular number contains a bar digit, you have to read it digit by digit, because one number is positive, second number may be positive, third may be negative, fourth may be positive. Accordingly, you have to read the number as digit by digit. So it is here all are positive, so you can directly read it as 1789, whereas as bar is contained, you read it as 179 bar 1. That means unit place has minus value. So this is 1790 minus 1 is nothing but the value remains same, only thing you have reduced 89 to 9 bar. Further, 1800 minus 11, again it gives same value. 2000 minus 200 minus 10 minus 1. So this all together gives 211. So 2000 minus 211, again they will be the same value as. So this number is known as normal number, whereas these numbers, they are known as vinculum number, because they contain both positive as well as negative digits. Now if you observe all these four values, all these four numbers, they have the same value 1789. But if you observe 7, 8 and 9, they are the three bigger digits in case of normal number. When we have converted it here, there are two bigger digits, 7 and 9 only. From here to here, there is only one bigger digits, and the rest are all small, whereas here all digits are less than 5, but their value is same. So the main purpose of converting any number into vinculum number is to convert the bigger digit into smaller digit. That is the main purpose. We can convert any number into vinculum number. Say for example, now let us take the numbers between 30 and 40, which are 31, 32, 33, 34, 35, 36, 37, 38 and 39. Place value wise, how we write these numbers? 31 is 30 plus 1, 30 plus 2 and so on up to 30 plus 9. So 31 to 35, they are the numbers near 30, whereas 36 to 39, they are the numbers near 40. So suppose if we come back here, so 39 it also means it is 40 minus 1, this one is 40 minus 2 and so on up to 40 minus 9. So 39 we were writing 9 at unit place, 3 of 30 at tens place. Now let us write minus 1, that is bar 1 at unit place, 4 of 40 at tens place. So 4 bar 1 means 40 minus 1 is 39. Likewise 38, 37 or 40 minus 3, 40 minus 2 and so on up to 40 minus 9. So 40 minus 9 is also 31. 40 minus 1 is 39. But if you compare 39 with 4 bar 1, here 9 is a bigger digit, whereas you have avoided that bigger digit here. 8 is a bigger digit, avoid it. Likewise 7, 6. But later on when you come over here, a smaller digit has converted into a bigger digit. Conversion is correct. 30 plus 1 is same as 40 minus 9. But the smaller digits, they have converted into bigger digits, which is not required. So if we consider a number 2768, in this number 7, 6 and 8, they are the bigger digits. So without converting the value as 2768, how to convert this number into a Vinculum number? So for higher digits, we apply the Vedic formula Nikhilam Navatash Charamam Dashataha, means last from 10, others from 9. We have learned what is the complements, and 10 complements from 10. Last from 10 means 8 and 2 is 10. Others from 9 means 7 and 6. From 9 means 6 and 3 is 9, 7 and 2 is 9. And another formula, Ekadikena Purvena, that is one more than the previous one. So to this smaller digit, we apply Ekadikena Purvena, or in general x plus 1. And here, last from 10, others from 9. So complementary from 10 of last digit, others remaining bigger digits, complements from 9, and give a negative sign. So x plus 1, so 2 plus 1 becomes 3, giving bar for these 3 digits, complements from 9, complement from 9, complementary from 10. So 7 and 2, 9, 6 and 3, 8 and 2, 10. Last from 10, others from 9. So this means place value wise it is 3000 minus 232, which is nothing but 2768. So this is how the conversion takes place. So suppose the number is, so all these are bigger digits. Apply the formula, last from 10, others from 9, and Ekadikena Purvena, one more than the previous one. So 3 becomes 4, the rest 8 and 1, 9 and 0, 7 and 2, 6 and 3, and last from 10. So 4 bar 1, 0 bar 2, bar 3, bar 3 is nothing but 3,89,767. But always it will not be that first number is smaller and others are bigger. There may be small and big number, combination of that. So how to convert? Something like this. So here we have to group it. Bigger digits with a smaller digit, for which you apply the formula. So 298 is nothing but 300 minus 2, or last from 10, others from 9, 9 and 0 is 9, one more than the previous one. So 300 minus 2. Here 3 is smaller itself, so we can group 179. So one more, last from 10, others from 9. So last from 10, others from 9, one more. So 30 bar 2, 32 bar 2 bar 1. It is nothing but 298, 3179. So just we will have to group it so that easily we can convert it into Vinculum number. So this is a number. How to convert? Just we will have to group it. Now 3876. 2888. 3121 is smaller itself. So these are the first group, second group, third group. Convert group wise using the same formula. From here also or here also we can write it. So we will convert this 4 bar 1 bar 2 bar 4 0. Now we have to convert this one bar 1 bar 1 bar 2 3 1 2 remains same 2 0 bar 1 bar 3. So observe these numbers. Just how many bigger digits are here in the normal number 876, 888, 987. Whereas in this case all numbers are below 5 but their value is same. So that's what it is required. We want to convert bigger digits into smaller digits. So now let us see how this vinculum aspect is used later on, because this vinculum aspect is useful in various operations such as addition, subtraction, multiplication, division. Wherever the bigger digits are there and wherever we want to convert it into smaller numbers, we can easily use this vinculum aspect. So the first one, let us begin with a number 19. What is the multiplication table of 19? So in case of 19, 9 is a bigger digit. So we will have to convert it into vinculum number. So 19 is 20 minus 1 or 2 bar 1. So when the converted value or otherwise, if the both digits are smaller one, the same number itself will be written on the top, and this number is known as operator. So this operator bar 1 is at unit place, so is known as unit place operator. 2 is at tens place, it is known as tens place operator. And the procedure for writing the multiplication table is go on adding the operator continuously. So for unit place, just add 9 plus bar 1, that means 9 minus 1. So 9 minus 1 is 8. Continuously go on reducing the number by 1 because operator is bar 1. So 8 minus 1 minus 1. Now tens place operator is 2. So go on adding 2 continuously. So 1 plus 2 plus 2, 11, 13, 15, 17, 19. So this is the multiplication table of 19. So if you want a table of say 29, it is 3 bar 1. So unit place is same as this, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Now to this number 2 we will have to add the operator 3. So 2 plus 3 is 5 plus 3 plus 3 So it is the multiplication table of 29. Suppose we want to write the multiplication table of 99. 99 being 100 minus 1. So it is 1, 0, bar 1. So these are 3 digits and these are 2 digits. So by giving 0, make the number 3 digits. And go on adding unit place operator followed by tens place operator followed by hundreds place operator. So 9 minus 1, it is the same as this. Now the operator at tens place is 0. So 9 plus 0 is 9, plus 0, 9. So it remains same as 9. And here the operator is 1. So 0 plus 1, 2, 3, 4. So 99 tens are 990. So this is how you can write the multiplication table. So now in these three tables, say 19, 29, 39, 49, 12, 99, there was no carryover of the digits. Whenever there is carryover of digits, it may be either positive or negative. How to write the multiplication tables? First we'll start with positive carryover. So let us write a multiplication table of 22. In case of 22, both digits are less than 5. So whatever number is there, that itself is the operator. So the unit place operator is 2. So go on adding 2 continuously. 2 plus 2 plus 2 plus 2. Now 8 plus 2 is 10. So in case of 10, you write only unit place. 1 is carried forward in the form of positive sign. You write the positive sign at the back of the number. That's all. So in this position, here you will have to add extra 1. That's all. Otherwise, now it is 0 plus 2. It is not 10 plus 2 now. It is 0 plus 2, 4. And again 10. So here 1 and here 1 you will have to add. So now it is, operator is 2 at tens place also. 8 plus 2 is 10 and this carried over 1 is 11 plus 2. 19 plus 2, 21 and this one 22. So if at all you want to continue further, 11s are, 12s are, 13s are also, add it and write it. 2, 4, 6, 11s are, 12s are, 22, 24, 26 and so on. So whenever we get a double digit, that there you write the unit place number with positive and later on add to the unit place whatever the operator is. In case of 34, both are smaller digits. So positive unit place operator is 4. 4 plus 4, 8 plus 4, 12 means 2 with positive sign. 2 plus 4, 6, 10 means 0 with positive sign. 4, 8, 12, 6, 10. So at these positions you will have to add 1. So the operator is 3. 3 plus 3, 6, 6 plus 3, 9 and this 1, 10, 13, 16 plus 1, 17, 20, 23, 26 and 1, plus 30, 33 and 1. Want to continue? And so on. So this is the multiplication table of 34. Now let us begin with the multiplication table where negative carryover is done. For this we'll start with the multiplication table of 18. In case of 18, because 8 is a bigger digit, we convert it into a vinculum number 2 bar 2. That means at unit place we have to reduce the number by 2. So 8 minus 2 minus 2. Now when we come to 0, 0 minus 2 is actually bar 2. but multiplication table, it doesn't contain a vinculum number, it is to be normalized. So what is to be done? Let us first complete till this position and later on we will carry on. Now at 10th position, 1 plus 2 is 3, plus 2, 5, 7, 9, 11. That means this is 1, 1 bar 2. When this vinculum number is converted or when it is normalized, its value is 1 bar 2 means 0, 8. So 1, 1 bar 2 means 108. So now let us again proceed with the similar fact. So when we get 0 minus 2 as bar 2, or whenever we get a negative number here at any position, just what you do, if you observe this bar 2 and 8, so 8 plus 2 is 10, so it will be always a complementary from 10 of the negative number. So 0 minus 2 is bar 2, the complementary from 2, complementary from 10 of 2 is 8 with negative sign, because now 11 has converted into 10. That means we are subtracting the number 1 from whatever number we get at a particular position. Later on, 8 minus 2. If at all we want to continue, 11, 12, 0 minus 2 is minus 2, or bar 2 means complementary from 10, is 8 with negative 6, 4, so here it is reduced by 1. 1 plus 2, 9 plus 2, 11, minus 1 becomes 10. 18 into 20 minus 1. And so on. So 10 the, 11 the, 12 the, 13 the, and so on. So let us take one more example. Multiplication table of 27. So 7 is a bigger digit. It is 30 minus 3 or 3 bar 3. So 7 minus 3 is 4, minus 3 is 1. Now 1 minus 3 is bar 2. Bar 2 complementary from 10 means 8 with negative sign. Just to put a minus sign into bracket, and later on you continue with whatever unit less number is obtained. 8 minus 3. Now 2 minus 3 is bar 1. So 1 plus 9 is 10. So 9 with negative. So at these two positions, reduce the number by 1. 2 plus 3, 11 minus 1, 16 and 3, 19 minus 1, 27, 10 the 2, and so on. So now when there is negative carryover or whether it is positive carryover, you can easily write the multiplication table. Let us take one more example. Multiplication table of 46. Here 6 is a bigger digit. It is 50 minus 4. So 6 minus 4 is 2. 2 minus 4 is bar 2. Bar 2 means 8 with negative sign. 8 minus 4 is 4. Then 0. Minus 4 means 6. 6 minus 4 is 2. 2 minus 4 bar 2. 4, 0, and so on. So 4 and 5, 9, 13, 18, 23, 27, 32, 36, 41, 46. So 46 10 left, 460. So this is how we can write any multiplication table. So depending on the number, there may be positive carryover or negative carryover, and we can proceed place value wise. First filling up unit place followed by tens, hundreds, thousands and so on. So suppose if you want to write a multiplication table of 2980. So 29. So we can convert it as 3 bar 1. 18 we can convert it as 2 bar 2. Now place value is continue. Here it is bar 2. So 6, 4, 2, 0. So here plus 2, 3, 5, 7, 9. Now it is 9 plus 2, 11. Minus 1 is 10. So 0 with positive sign. In this case 9 minus 1, 8, 7, 6, 5. Minus 4 is 5, 4, 3, 2, 1. So there is no sign here, so directly we can add 3 and write. So 2918 into 10, 29180. So this is how we can write the multiplication tables of any number. So now let us begin with addition and subtraction. As we are familiar with the addition of digit by digit, because we have learned addition for so many years. So 9 plus 8, 17 plus 5, 23 plus 6, 29 and so on. Then while adding we write 29 means 9 and 2 carry over and so on. But when a child is there in the first, second, third standard, it is very difficult for him to add continuously. And there, how to cope up with this addition. And here the Vedic Sutra Shuddha, or in English it is known as dot. So a dot method is used. How it is used, let us see. So whenever a sum of 2 digits or whatever number, whenever it becomes 2 digits, at that time only we carry out. So for example, 9 plus 7, now we are going to start with this. We know it is 9 plus 7 is 16. So this one is carried out at this position itself, giving a dot in place of 1. And we'll remember only 6. So 9 plus 7 is 16. 16 means give a dot in the same position at 10's place. If there is number over here, over this particular digit, you give a dot. Remember only 6. Don't remember now 16. Now 6 plus 1, 7. 7 plus 5, 12. So 7 plus 5, 12 means dot 2. So remember, give dot, remember only 2. 2 plus 7, 9. Now in this tens position there are 2 dots whose value is 1, 1. So this is the addition is carried out. Now 3 plus 7 is equal to 10, means dot 0. 0 plus 6 is 6. 6 plus 7 is 13, means dot 3. 3 plus 1 is 4. So 2, now dot is given means its value is increased by 1. 2 plus 5, 7. 7 plus 5 is 12. 12 means dot, remember only 2. 2 plus 3 is 5. 5 plus 1 is 6. 1 dot. 164. So 5 plus 8, 30 means dot 3. 3 plus 1 is 4, 4 plus 2 is 6. 1 plus 3 is 4, 4 plus 8 is 12 means dot 2, 2. 4 plus 3 7, 7 and 6 13 means dot 3 and 6, 9 and 1. So this is known as the dot method of addition. So in case of subtraction also, the dot method is used. In what way, that we will see. So 5 minus 2 is 3, 6 minus 5 is 1, 7 minus 4 is 3, 8 minus 3 is 5, 2 minus 1 is 1. So this is known as minuend. This is subtrahend. So you can easily carry out minuend minus subtrahend. 5 minus 2, 6 minus 5, 7 minus 4, like that. So there is no problem when you can subtract subtrahend from height. But suppose if the number is such, so 6 minus 3 you can easily do, but 5 minus 3, because you cannot subtract, you borrow 1, then make 15 minus 8, 7, then whatever has been borrowed, you are giving it back. But in this dot method, what you do is 5 minus 8, you cannot do. First give it dot at next place. That is the first part. Now subtraction is the reverse of addition. Complementary from 10 is add. So complementary from 10 is 2 over here, 5 and 2 is 7. Even otherwise, 15 minus 8 is 7. So when a dot is given, its value is 4, 6 minus 4. 7 minus 8, we cannot, so give a dot. Complementary is 2 again, 7 and 2 is 9. 8 minus dot means 1, 1, 7, 9, 7. Now when we are familiar with vinculum, directly there is no question of adding or subtracting, borrowing, etc. What is 5 minus 8? It is bar 3. 6 minus 3, 3. 7 minus 8, bar 1. 8 minus 0, 8. 2 minus 1, 1. So what is, convert a vinculum number into normal. 8 bar 1. This one is 1. 8 bar 1 means 80 minus 1. 3 bar 3. 17927, 17927. So this is much easier, but for children, dot method is useful. So now let us come back to vinculum. 3 minus 5 bar 2, this is 7, 8 minus 9 bar 1, 5 minus 7 bar 2, 3 minus 3 0, 4 minus 2. So automatically this minus this, whether it is a bar digit or positive, directly you write the value and then convert it into vinculum. 2021 means 7 bar 2 means this cancel. So within no time you can write such subtraction of this. Now let us take an example which has mixed addition and subtraction. So this plus this minus this minus this plus this. So what actually we do is, the conventional method involves separating all positive numbers together and adding it. So conventional method, step 1, all positive additions. Step 2, all negative numbers adding together. And step 3 involves finding the difference between step 1 and step 2. So this involves space, time, and we are wasting our energy. Whereas here, directly in a single line, we can carry out. Just for understanding before this, we'll say 3 plus 5 is 8. So this 5 minus 3 is 2. 5 minus 7 is bar 2. 5 plus bar 7 is bar 2. Because 5 plus bar 7 means minus 7, it is 2. So if you observe these two examples, 5 minus 7 and 5 plus bar 7. So minus I have changed to plus, and plus I have given a bar on top of the digit. So its value remains same. So whatever I am doing it is for negative values. So just make it positive, give a bar on the number. Go on adding. That's all. Now this is 6 and minus 6. Everything cancels. 8 and 1 is 9. This 3 and this 3. Plus 3 and minus 3 cancels. Remaining is 5. This is 7. 4 and 3 7. Everything cancels. This is 1. This is 6. This is 6. This is 4. Directly we can get the answer as 4159. So these these 4 are minus numbers. Give just plus sign. Plus, plus, plus. Minus 1, minus 2, minus 4, minus 8. This is minus 8 and this is 1, means bar 7. Minus 1 plus 1 cancels. Minus 3 and 5 is 2. 2 minus 1 is 1. 1 minus 1 is 0. 8 minus 3 is 5. 5 minus 2 is 3. 3 minus 2 is 1. 1 minus 1 is 0. 4 minus 1 is 3 minus 2. 3 minus 3 cancels. 6 minus 2 is. So here only thing is answer is in vinculum form. Just we'll convert it into normal number. 2 bar 7 means this is the answer. This is how the mixed addition and subtraction can be easily carried out directly in a single step. Now let us begin with various Vedic methods for multiplication. The conventional method for multiplication, it involves more space, and to solve the example it requires more time also. Whereas Vedic methods are dependent on what is known as nature of number. And as far as Vedic mathematics is concerned, this nature is when the numbers are near base, when the numbers are near sub base, and the third one is general. Near base, as we have already studied earlier, it is 10 and powers of 10, they are known as base. That means 10, 100, 1000, 10,000 and so on. When the number is near base, $20, $30 or say 400, 5,000, etc., they are known as sub base. So when the numbers are near subbase, one more method, and which are not near base or not near subbase, they come under the category general. So the Vedic mathematics, especially for multiplication, division, squares, cubes and so on, minimum 3 methods are there. One, when the numbers are near base, next numbers are near subbase, and the third one a general one. So now we are dealing with multiplication, and in multiplication we will start with numbers near base. So in this case, in case of multiplication, we have a multiplicand, multiplier and their product. It gives the answer. So for example, when we have to multiply 104 into 108. So how to solve this example? Conventionally, we multiply by unit place into 100th, followed by tens place, followed by hundreds place. So we require 3-4 steps and then add to get the answer. Whereas in this case, both numbers are near 100. First number is more than that by 4. Second number is more than that by 8. And when we want to find the answer part is divided into two parts, right hand part and left hand part. Right hand part is the product of 4 and 8, and left hand part is the addition of one number and deviation of the other. So 104 and 8 gives 112. So 11232 is the answer. So one thing we will have to learn here is what is known as deviation. Deviation D is known as number minus base. So when the number is say 104, this number is near 100, that's why the base is 100. So 104 minus 100, it gives 4. So 4 is known as deviation. If the deviation is 1012, 1000 is the base, so difference 12 is known as deviation. When the number is less than the base, for example, number is 994, this number is near 1000, so number minus base, it is minus 6, and we have already learned in Vinculum number, a bar is given on top of the digit whose value becomes negative. So in case of 994, deviation is bars. So the general formula for the multiplication of two numbers near base. So when we have to multiply, first multiplicand into multiplier, let us call it as n1 and n2. Just give a little gap, write their respective deviations d1 and d2, so that the product d1 into d2 is the right hand part of the answer, and left hand part of the answer is this is the answer. And number of digits involved in the right hand part. It is the number of zeros in base. So when the base or both numbers are near 100, d1 into d2 will be 2 digits. When the base is 1000, it will be 3 digits. When it is 1 lakh, it will be 5 digits. If it is not, if this product is not 5 digits, then we will have to adjust accordingly so that right hand part will be of number of digits which is equal to the number of zeros in the base. Now let us begin with some examples wherein both numbers are near same base. One example, say 12 into 13. In this case, both numbers are near 10 as a base. If we consider another example, 108 into 107, where both numbers are near 100. In this case also, both numbers are near 1000. Now, to find the deviation, in this case, both numbers are near 10. So, from 10, both numbers are more than that by 2 and 3. So, leaving a gap, just write only 2 and 3, which are the deviations. In this case, it is 8 and 7, and in this case 23 and 11. So the answer part is bifurcated in two parts, right hand part and left hand part. Right hand part is product of these deviations, 3 to the 6, whereas left hand part is one number and other deviation. So 12 plus 3 or 13 plus 2, both will give 15. So answer is 156. In other case, deviations 8 and 7, the product is 8 7 the 56, and when we add either this or this, 108 plus 7, so the answer is, in the third case, 23 and 11 is the deviation, the product of 23 into 11 and 1023 plus 11. So almost mentally we can write the answers. Now the one way of writing the deviation is like this, whereas to get the correct number of digits in the right hand part, which is equal to the number of zeros in the base. In this case it is 1000, whereas 2, 5 and 3 digits, 100 base 2 digits, 10 base 1 digit. That is the answer. Another way of writing these deviations, as the base is 100 here, instead of writing 8, here itself you write deviation as 08, so that you will come to know that the answer part must be only 2 digits. In case of 1023, instead of writing 23, you can write it as 0 to 3. That means the answer part is only 3 digits. So in case of, so you can write the deviation as 4 digit, because 10,000 is the base. So if the number of digits are either less or more than the number of zeros in the base, how to cope up with the right hand part of the answer, we'll see. So in case of 113 into 109, the deviations are 13 and 09. The right hand part of the answer is 13 into 9, which is 117. But 117 is 3 digits, whereas our base is 100, which means that right hand part must be only of 2 digits. So you just write the third digit slightly downwards and remaining 2 digits, the answer which we want, like this. Add these two together as in left hand part. Now the correction is this excess digit is added to the left hand part, which is 122 plus 1. This is the answer. Both numbers are near 1000. The deviations are 007, 003. Now 7 3s are 21, which is 2 digits, and we need 3 digits. Hence 1, 2 and 3 give 0 at the back. This is very important. The third digit, because the product is only 2 digits and we need 3 digits. The rest part is same. So the answer is this. Now all the examples which we have seen, they had positive deviation. When the deviation is negative, then how to solve the examples? Say for example 94 into 91. Both numbers are near 100 and the deviation in this case 94 minus 100 is bar 6 and here it is bar 9. Right hand part, product of deviations, minus into minus is plus. 6 9s are. It is 2 digit itself, so no correction is needed. Now adding these two, either 94 minus 9 or 91 minus 6. This is the answer when both numbers are near base but less than the base. So both numbers are near 1000. In this case, the deviation is minus into minus plus 2 digits. So to get 3 digits, 0 is added. So this minus this is, so the answer is 97906.8. There is possibility that one number has positive deviation, another number has negative deviation. For example, 107 into 94. So in this case, both numbers are near same base only, whereas in one case the deviation is 0.7, in another case the deviation is minus 6 or bar 6. So the product of these two deviations, plus into minus, So this will be minus 7 6 42. Either this plus this, 107 minus 6, or 94 plus 7. But the answer is in vinculum form. We'll have to normalize it, and you know how to convert vinculum number into normal number. It is last from 10, others from 9, one less. So this is the answer. Now let us begin with the second set of multiplication of two numbers where both numbers are near same subbase. So already you know what is subbase. It is in between 10 and 100. All tens means 20, 30, 40, etc. Later on between 100 and 1000, 200, 300, 400, etc. After 1000, 2000, 3000, etc. So when the numbers are near these subbases, both numbers near same subbases, how to carry on the multiplication. The earlier set of multiplication where both numbers were near same base as well as the numbers near same subbase, they are called as Nichilum method. Because for finding out the deviations of the numbers which are less than the base by the formula Nichilam Navatas Charamam Dashataha, that is last from 10, others from 9. This formula we are using, and that's why this method is known as Nichilam method. Now let us take some examples where both numbers are near same subbase. The procedure remains same, only the thing is the deviation will be from subbase and not from base. So here the deviation is 3, here it is 1 from 20. In this case the both numbers are near same subbase 300 and their deviations are 0, 4 and 12, and in the third case they are near 4000 and the deviations are earlier we have seen that when numbers were near same base, we were finding out deviations. Right hand part d1 into d2, left hand part was one number and deviation of the other, or n2 plus d1. Here the only change from this formula in this case is a ratio comes into picture. For left hand part, what is known as R. R is the ratio which is subbase upon base. Now in case of 20, it is 2 times 10 as base. So 2 is the ratio, or we can just see subbase is 20, base is 10. So R is equal to 2. In this case 300 upon 100, 4000 upon 1000. So the ratio here is 2, ratio here is 3. ratio here is 4. So as usual, d1 into d2, 3 ones are 3. Number plus deviation, 23 plus 1 or 21 plus 3 gives 24. But only change is you will have to multiply the left hand part by a ratio 2. So 24 into 2, and this 483 is the answer. In the other case, 3 is the ratio. Number plus deviation, 12 into 4. So 304 plus 12, 316 into 3, and it's 48. And in the other case, 4 is the ratio. Number deviation. So only in a single step we can find out the product of two numbers where both numbers are near same surface. And here now the deviations may be positive, both deviations may be positive, both deviations might be negative, or one deviation positive, another deviation negative, and so on. So we will have to be sure that the number of digits at the right hand part depending on the number of zeros in the base. For example, if 28 into 27, both numbers are near 30. So from 30 the number is 28, so deviation is minus 2 or bar 2, here it is bar 3. So bar 3 into bar minus into minus plus, 3 to the 6, 28 minus 3 is 25, ratio is 3. So 756 is the answer. In the first chapter we have seen how to check the example, and here we can check by Bijang. The Bijang of this number is 8 plus 2 10 means 1, 7 plus 2 9 means 0. So the Bijang of question is 1 into 0 is 0, and Bijang of 7 5 6 is also 0. That means our answer is correct. So in one step or two steps we find out the answer and check whether the answer is right or wrong. If it is 189 into 193, both numbers are near 200, deviation in both cases, here it is bar 11, bar 7. So minus into minus plus, 11 7 are 77, 189 minus 7, and you have to multiply by a ratio, that is 2. So 2 into 182. This is the answer. In the third case, let us take one number less than the base, subbase, and another number more than the subbase. Here, in both cases, 300 is the subbase, so we will have to multiply right hand part, left hand part by ratio 3. Deviation here is 9 8 is 72. One deviation is positive, one deviation is negative. So minus into plus gives minus, 9 8 is 72, and so this is bar 72. And this is a Vinculum number. We will have to normalize it. It is so 89,628 is the answer when we multiply 291 by 308. So let us take two more examples. Both numbers are near 200 and the deviations in each case, here it is positive, negative, so plus into minus is minus, multiply by ratio 2. The Vinculum number is normalized. So the answer is 41,193. So 43 into 44. Both numbers are near 40. Deviations are 3 and 4. So 40 is 4 times 10. So 4 is the ratio. 4 times 10. 10 means 10 is the base. So right hand part must be of single digit, but the product 4 3s are 12 is 2 digit. So 1 digit is carried forward. 4 3s are 12. This one will be later on carried out. And 43 and 4 is 47. So this one is carried forward, so that the answer is 1892. So 1892 is the answer when 43 is multiplied by 44. So excess digits are carried over later on after completion of the left hand part. If the number of digits are less, 0 is given at the back of the number. So this is about the multiplication of two numbers near same surface. So first one was the multiplication of two numbers near same base. Second set was multiplication of two numbers near same subbase. And now the third part is when one number is near different base subbase. So one number might be near base, another number might be near subbase, or both base will be changed, both subbase will be changed. So there is a variety of problems we can create under this category. So for example, if the number is 203 into 1005, how to carry out such example. So before proceeding to actual example like this, we will see what we were doing earlier without knowledge, taking one example of near base. So here the deviations are 6 and 8. So indirectly we were multiplying deviations and then adding this. But in actual fact, what we are doing, because the base, both numbers are near same base, it makes no difference there, but here it will make a definite difference. So just you write the number, leaving a gap, write the deviations, later on in the bracket, whatever base or subbase is there, you write it in the bracket. So in this case, 100 is our base. And now just observe how many common zeros we can cancel. So here we are cancelling two zeros, which indicates number of zeros in the right hand part. So 2 zeros were cancelled. Therefore, the product D1 D2 or 6 into 8, 48. This part must be of only 2 digits. Here earlier we were adding only 106 and 8. Now after cancelling these 2 zeros, what is left is 1 here. So instead of adding 106 and 108, we were actually doing 106 into 1, which is 106 itself. 8 into 1 after cancelling 0 is 8 itself. So we were not multiplying or taking this hard part into consideration, and we were just adding 106 plus 8 or 106 into 1 plus 8 into 1. So this was our answer. In the next case, what we were doing was writing the deviation part. We were adding number and others deviation and then multiplying by ratio. In this case it is 2. So we were multiplying by 2. So that is our answer. But like this, what we were doing is just into bracket write this subbase, cancel common zeros. So here 2 zeros were cancelled, indicating right hand part is of 2 digits. Now 204 into 2 plus 6 into 2 means common is 2. This 2 comes over here in the form of ratio earlier, and 204 and 6 is 10. So now whatever number is left we are multiplying, and that's what we are writing it in the form of ratio. Now in this example, one number is near 200 whereas other number is near 1000. So how to multiply such numbers? So in this case, from 200 the deviation is 3. Write it into bracket whatever the base or subbase is. Here from 1000 so 1000 is the base. But now how many common zeros we can cancel? Only 2 common zeros we can cancel. And hence, now like the common number 2 and 2 we don't get. Here we get 2, here we get 10. Or depending on the number, whether it is near one subbase or another subbase or base, whatever it is. So accordingly, we will have to manipulate. So what you have to do, one number and whatever is left in the others bracket, multiply. So 1005 into 2 is plus deviation of one number, remaining part of the other. So 3 into 10 is 30. We can do it another way also. 203 into 10 and other deviation and first bracket, that 5 into 2 is 10. So either you do like this or like this, you will get the same left hand part. And the right hand part, because you have cancelled 2 zeros, product must be of 2 digits. 3 5s are 15. That itself. So the answer is 204,015. Now let us take one more example. So 12 is the deviation, 200 is the subbase, here 4 is the deviation, 300 is the subbase. We can cancel 2 zeros, that means this part is of 2 digits, 12 for the 48. If we do like this, then 212 into 3, 636 plus 4 to the 8, or 304 into 2 is 608 and 36. So either this or this, whichever you feel better, you can do it, which can be done orally. 636 plus 8 or 608 plus 36. So our answer is 64448 is our answer. This number is near 1 lakh, this number is near 30,000. Deviations are 41 and 5 respectively. Into the bracket 1 lakh, and here it is 30,000. So how many common zeros we can cancel? So 4 common zeros cancelled. So the right hand part is of 4 digits, but the product is 41 into 5 is 205, which is 3 digits. To make it 4 digits, we will have to give 0 at the back. Now, whichever is easy, whether this into 10 plus 41 into 3 is easier, or this into 3 and 5 into 10 is easier, that you have to decide accordingly. You just see. So this into 10 is much easier. So 3,050,50. So this we have done. So this we have to do 123. So the answer is this is the answer. Otherwise, by conventional method, you could just see how much time you would have taken to solve this and how many steps are needed. So you are saving the space, you are saving the time, and of course energy. So in the similar fashion, instead of 2 numbers, if there are 3 numbers, just we will take 1 or 2 examples near same base. So it is like n1 into n2 into n3. All the 3 numbers are near same base. Their respective deviations will be d1, d2 and d3. So in this case, because there are 3 numbers, the answer is bifurcated into 3 parts. Each part we will have to calculate separately. The first part, product of all deviations. Here, what are the possible combinations of 2 deviations at a time? It's known as sigma d1 d2. So in what ways we can multiply two numbers. So d1 into d2 we can do, d1 into d3 we can do, d2 into d3 we can do, and it is the summation. Or just I will write in detail, d1 d2 plus d2 d3 plus d3 d1. And the third is any one number and deviations of other two. So this part is n1 plus d2 plus d3 or n2 plus d1 plus d3 or n3 plus d1 plus d2. So anyone you can. So let us take one simple example. (102 into 104 into 106). So all these three numbers are near same base. Respective deviations are 02, 04, 06. So first right hand part is 2 into 4 into 6, 6 4s are 24 to the 48. As our base is 100, this part is 2 digits, next part is 2 digits, rest part is left hand part. Now 2 4, 2 6 and 4 6, these are the products. Will be 2 4s are 8, 8 plus 12 plus 24, 44. And any one number, say 102 plus 4 plus 6, so 102 and 10. So actual answer is 112 4448. So either we can write 345 or 003, 004, 005, which indicates that these parts are 3 digits. Otherwise 345 just product, and because you know it is near thousands or 2000s, you can just adjust the number of digits here. So 5 4s are 23, the 60, but we want 3 digits, means the, or 60. 1 2 3, 1 2 3. Now this and this. So now the middle part. So this part remains same. Middle part into ratio. Now the ratio 2000, these numbers are near 2000, which is 2 times 1000. So R is 2. So this into R ratio. And the third part is this 2003 plus 4 plus 5 or 2005 plus 4 plus 3 or 2004 plus 3 plus 5. Everything will give 2012 multiplied by R square. R is 2, its square is 4. So 2012 into 2 to the 4. (47 into 2). And 060. Here the product is 2 digits. We want 3 digits because of thousands. So it is 094. So the answer is 804809460. So this much big answer within a step we can carry out. So same can be continued for 4 digits and other things. Just I will give the formula only. So when there are 4 numbers, answer is bifurcated in 4 parts. Here all 4 digits product of, then comes possible combinations of 3 digits, D1, D2, D3, this D3, D4, and these are the 4 combinations here. Then all 4, all 3, all 2, and only 1 is N1 plus single is D2 plus D3 plus D4. This is how we can carry out. So D1, D2, so there will be 4 such combinations as shown above: D1, D2, D3, D2, D3, D4, D1, D3, D4, and D1, D3, D4. They are the, D2, D3, D4. Here there will be 6 combinations. Because there will be only 2, D1, D2, D1, D3, D1, D4, 3 combinations. D2, D3, D2, D4, 2, 3 plus 2, 5 combinations. D3, D4, 6th combination. So addition of all those products will be here, and here there will be 1 number and other 3 deviations. Only thing here, in all these 3 cases, you will have to adjust for the number of digits. If the numbers are near 100 to 2 digits, 1000 means 3 digits, 10 means single digit. That is the only adjustment you have to carry out. But in a step or two, with little calculations in each step, easily you can write the answer in 1 or 2 steps. So initially you will take how to multiply any number by 5. Suppose if we take in the routine process, we carry on the multiply the 40, carry over 4 and so on. Whereas just by observing, we can write the answer as. So how to carry out such examples? Now we have seen in the multiplication, when the numbers were near base, almost mentally we were writing the answers. In the similar fashion, how we can bring 5 nearer to the base, as it is 10 divided by 2. So instead of multiplying by 5, we will be dividing by 2. Just we'll see. Stepwise, first I will start. Instead of 5, I will write. So automatically it is 3480 divided by 2 and carry over 1. So whatever be the number, instead of multiplying by 5, dividing by 2 is much easier. So 1, 2, 3, 4, 5, 6, 7 into 5. What is the answer? So just for your reference, give a dot so that you are multiplying by 10. You should remember. For that purpose, either you give a dot or cross, so that up to this digit you will have to divide by 2. And then mentally you start dividing by 2. 2 6 are 12, 2 1s are 2, 2 7s are 14, 2 2s are 4, 2 8s are 16, 2 3s are 6, 2 5s are 10. So this is the answer when you multiply by 5. When you want to multiply by 25, now here also you can bring nearer to base. So 100 divided by 4 is 25. So instead of multiplying by 25, give 2 zeros in front of the number and divide by 4 to get the answer. So instead of 25, you can divide by 4, and for this 100, you can just have 2 cross marks. It is for your reference, or 2 dots, whatever it is, and then start dividing by 4. 4 to the 8, now it is 0. 4 5 the 20. 4 7 the 28. 4 7 the 28. 4 5 the 20. So 205775 is 8231 into 25. So this is how within no time you can carry out the multiplication by 25. If it is 125, it is 1000 divided by 8. So instead of multiplying by 125, you will be dividing only by 8 to get the answer. So it is 1000 divided by 8. So for 1000 you give 3 cross marks or 3 dots, and now start dividing by 8. 8 for the 32, 8 for the 32, 8 7 the 56, 8 for the 8 3 the 24, 8 6 the 48, 8 2 the 16, 8 5 the 40. So 3 5 7 8 9 into 125 will give 4473625. Otherwise, to multiply by 125, how much time you would have needed, you can just imagine. So the same way you can continue for 625, where it is. So multiplying by 625 is easier, or dividing by 16 is easier. You can just imagine. So in this way, you have to bring the numbers nearer to the base, so that with smaller number you can divide and get the answer. So any number into 11. Say for example, what is 43 into 11, or 21 into 11, or 62 into 11. So just by observing you can write the answers. So how it has come, just observe. 4, 3, addition of 4 and 3 is at the center. 2, 1, 2 plus 1 is 3 at the center. 6, 2, 6 plus 2, 8 at the center. Only thing is, when the number 83 into 11, now you can write 8 and 3, but what is 8 plus 3? 11. It is a 2 digit. 11 means 1, carry over 1, so this one is to be added, so 8 becomes 9. That is the only change. You have to just carry on the numbers. When the addition of 2 digits appears 2 digits. So this is as far as, okay, why we are doing like that, just observe. We will take now here also 11 is the number which is nearer to 10. So give one cross at the back, one cross in front. So when you want this number into 11, what you will be doing? Add, just continue it. This plus this. This plus this. 31201 into 11 is 4743211. Just you are giving it 1 0 here, 1 0 here, or for that matter 1 cross here, 1 cross here, and then adding two digits simultaneously. You need tens, hundreds, 100,000 and so on. Wherever if the sum is double digit, you can carry on. So this plus this is 5. 8 plus 5 is 13, carry over 1. 8 plus 3, 11 and 1, 12, carry over 1 and 4. So this is how in a single line you can carry out the multiplication by 11. Okay, why we carry out like this? We take some simple example. Which is nothing but so 34 into 10 is 340 plus 34 into 1 is 34. So in case of 34 we are giving 1 0 front, 1 0 back, and then we are adding 0 plus 4 which is nothing but this, 4 plus 3 which is nothing but this, 3 plus 0 which is nothing but this. So instead of multiplying by 11 fourths of 44, carry over 4 and other things, just you can give 1 cross front and back and continue with the addition of two digits. You need tens, hundreds and so on. If it is 111, what is to be done? It is in a similar fashion. Now the number is near 100. That's why you give 2 zeros front and 2 zeros back. Now 111 contains 1, 2, 3 digits. You have to add simultaneously 3 digits. So these 3 digits addition is 1. These 3 digits 1. 1 plus 0 plus 2 is 3. 0, 2, 1. 2, 1, 3. 1, 3, 4. 3, 4, 0. 4, 0, 0. So this into 111, directly you are writing 47863311. So this is how multiplication by 111 can be carried out.